Welcome to today's tutorial. So in this tutorial we're going to be discussing how to find dydx by implicity differentiation, and also to evaluate the derivative at the given point. Okay, so if you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button, and then also click the notification button so that you get notified by every video that I'm going to be posting. Alright, so let's quickly begin to find the derivatives. So I'll start with the first one. Yeah, so the first one is simple. We have, so the question is xy. So I'll start with a. So we have xy is equal to 6. Then the point has been given to be -6, -1. Okay, so finding dydx using implicit differentiation of this one can be done in two ways. So if you want, you can first make y the subject of the formula, and then you differentiate the normal way. And then the other way you can differentiate this is by using the product rule, since you have these two functions that are multiplying. Yeah, so how can we use the product rule? Okay, so let us consider the first function as our u. So let's say let u be equal to x, then v be equal to y. So we find u prime is equal to 1, and v prime is equal to 1 as well. But for this one, since we're differentiating with respect to x, we always have to add dy dx. So we say v prime is equal to dy dx. The reason why I'm finding u and v is because the product rule applies when you're differentiating two functions. When you're differentiating a function that has two functions that are multiplying themselves. For instance, if you have f of x is equal to u times v. So to differentiate this, to find f prime of x, you always have to say v times u prime, then plus u times v prime. So this is what we call the product rule. So now let us quickly plug what we have found into this expression here. So now we have, in other words, we're finding the derivative. Yeah, so differentiating this part, the first part, this one, we are going to say our u. Let me follow the way this is. So I'm going to say a v. My v is y, so I'm going to say y. So I'm going to say y times u prime. Which one is u prime? This one here. So y times u prime, and then plus v. So u prime is 1, and then times we have u times v prime. So the value of u is x, then v prime is simply just dy dx. Then we say this is equal to, the derivative of 6 is simply just 0. Okay, so we have we have to make dy dx the subject. So take this y to the other side of the equal sign, so that this side will just remain with x dy dx. Then this one will be equal to negative y. Then when we divide by x on both sides, we're going to have dy dx is equal to negative y over x. So remember, this expression can also be made in such a way that y can be the subject. Yeah, or let me not even say that. Let me not even go to that point. Let me just say this is the derivative of dy dx in terms of x and y. So we can now find the value for dy dx at the point -6, -1. So meaning we just replace -6 and -1 in this derivative. So we're going to say dy dx at this point, which is negative 6 comma negative 1, will simply just be equal to, okay, so dy dx at that point is just going to be equal to negative, and then while there is y, I'm going to put negative 1. Then while there is x, I'm putting negative 6 there. So this answer will simply just give us negative 1 over 6. Let us see if we're going to find the same answer after making y the subject and then simplifying the whole expression. I mean differentiating the whole expression. So we're going to have something like this. If we make y the subject in that expression, we're going to have y is equal to 6 over x. Then this can also be written as 6x to the power negative 1. So dy dx is simply just going to be equal to negative 6. So this will be equal to negative 6. Yes, so this will be equal to negative 6. And then while negative 6, when you differentiate this will be negative 6x to the power negative 1, rather negative 2, since we're going to subtract by negative 1 from the power there. So our dy dx becomes, so this is just a normal of differentiation. This is not implicity. And then implicity is the first part which I did. So we have negative 6 there. So this can also be written as negative 6 over x to the power 2. X to the power 2. Yeah, so if we make x in this in this expression as the subject, let's try to make x the subject of the formula. We're going to have 6 over y. So I'm just trying to prove if my solution, this one, is correct. So 6 over y is the value of x. So let us try to put 6 over y while there is this expression there. Or while there is x. Let's see if what we're going to get is going to make sense. Okay, so when we replace it there, we're going to have dy dx is equal to negative 6, and then everything over 6 over y. Then we say this is squared. Okay, I see why the I think what we can do is this. Since we know that this x is squared, we can replace one value of x. Okay, let me do this. I just want to prove if my solution is correct before we can proceed. Okay, so we can say dy dx is equal to, we have negative 6 on top, and then down there we have two x values. So we can say x times the other x. I'm going to replace it with that. So if I replace the other x with 6 over y, you discover that this 6 and that 6 will cancel. Then since this one can also be written as dy dx is equal to 1 over x over y. Of course this one is negative because negative 6 and this 6 was negative on top. So this can also be written as dy dx is equal to y over x, which is just exactly as what we found there. Okay, so this is correct. So this is how you solve derivatives. Okay, so let's quickly move on to the next question. Okay, so the next question is also straightforward. It's not something that should give us problems. Okay. I'm just trying to clear up the board, the screen, so that we have enough space to solve the next question. Okay, so the next question is this one, which is y to the power 3. Let me just reduce the size of the brush. Okay, so we have y to the power 3 minus x to the power 3 is equal to 4. So differentiating this using implicity, we're going to differentiate it the normal way. We're going to differentiate the whole function with respect to x according to the question there. So this is going to be 3 times the coefficient of y here will give us 3, and then we say y to the power 3 minus 1, we get 2. But since we're differentiating y with respect to x, we say dy dx. We have to write dy dx there. Then we say minus, then x to the power 3. When you differentiate this part with respect to x, this will give us 3x squared. Then this is equal to, differentiate 4 there, you get a 0. So just make dy dx the subject. So we take this to the other side of the equal sign, then divide everything by 3y squared. So we're going to have dy dx. We're going to have y squared dy dx. 3y squared dy dx is equal to 3x squared. Divide everything by 3y squared. Divide everything by 3y squared. The answer is going to be dy dx is equal to x squared over y squared. So this is what you're going to have as your dy dx. So now we just have to replace this expression, this point there, to get the answer. So we say dy dx at the point where x is equal to 2 and y is equal to 2 is equal to, because I've just gotten these 2 points there, y is equal to 2 and x is equal to 2. This is just going to be equal to, we replace them there, so we have 2 to the power 2 over 2 to the power 2. So the answer will just be 4 over 4, which gives us 1. So same applies to this expression here. We also have to solve it in the same way I've solved this one. So except that in that expression we need to use quotient rule at some point to solve it, because we have 2 functions that are dividing themselves. So let's quickly do it. So of course I'm going to solve random questions from this question, and I'll leave some for you to practice as well. So we have this one here. So we have y squared is equal to x squared minus 49 and x squared, over x squared plus 49. So we have y squared is equal to x squared minus 49 over x squared plus 49. So differentiating this part is straightforward. So this part will just give us 2y dy dx. But this other part we're going to use the quotient rule. So we're going to say, we know to say f prime of x according to quotient rule is v, u prime minus u v prime, everything over v squared. So for this question, for quotient rule, should always make sure that you start with v this side. Once you just switch them, you get your solution wrong. Or in other words, you start with the denominator. Yeah. So the denominator. So if we say our u is equal to the numerator, which is x squared minus 49, then our u prime becomes 2x, because when you differentiate this part we get 2x, differentiate this part we get a 0. Then if we say our v is equal to the denominator, which is x squared plus 49, means that our v prime becomes 2x as well. So let us just replace them in this expression. So we have x squared, rather we have this expression here. So we say v minus u prime, v u times u prime minus u times v prime. So we start with v. So v is x squared plus 49, x squared plus 49, x squared plus 49, that's our v, times u prime, which is 2x. Then we say minus u, which is x squared minus 49, and then times v prime, which is also 2x. Then we divide everything by v squared. So v squared is simply just x squared plus 49. We square this. So this side we have 2y dy dx. Then the other side we simplify. So when you simplify this expression, you discover that we're going to have something like this. 2x times x squared, we have 2x to the power 3. Then plus, then we have 2x times 49. You get so 2x times 49. Same applies to this other part. We're going to get the same. Okay, so this is just going to be okay, sorry for that. Okay, so 2x times 49 will give us 98x. Yeah, so this will give us 98x, and then here we'll get 2x times negative times x squared, we get negative 2x cubed. Then negative times negative 49 times 2x, we're getting positive 98x. Yeah, so this is what we're going to get. Then everything divided by x squared plus 49 squared. So we have 2y dy dx is equal to, so we can see that this minus that will give us a 0. Then when you add 98, when we add 98 and 98, we're getting 196. So we're going to have 196 when we add this one and this one. We're getting 196x, and then everything over x. We're going to get everything over x squared plus 49, then squared. So to make dy dx the subject of the formula, we're just going to divide everything by 2y. So we're going to divide everything by 2y. So if we divide everything by 2y to make dy dx the subject, we're going to have 196 x over 2y times x squared plus 49 squared. So 2 can go into 196 to get dy dx as is it 98x over y times x squared plus 49 squared. So this is simple. This is how you find your dy dx using this expression. So now we find dy dx at this point. So dy dx when x is equal to 7 and y is equal to 0, simply just be equal to, we just replace what you have here. The value of x, you put it where there is x, and then the value of y, you put it there. Of course, when you look at this will be undefined because of this 0 here. Okay, so let's quickly move on to the next one. Let me pick a different question. Okay, so this one is also straightforward. I need to pick this one, but it's also straightforward. Okay, let's see which one can we pick. This one is also straightforward. Okay, I think this one at least. Yeah, so this one you can solve it using two methods. Yeah, so you can solve it using two methods. You can first express it into a compound angle formula and then differentiate, if that's the best way you can solve it. But the other way you can solve this is just direct, the way it is, tan x plus y. Use what we call chains rule. So you just make this part as your u, and then you differentiate your u, then you multiply by the derivative of tan. So the derivative of tan is it sec squared x? Yeah. Okay, let me just be writing what I'm saying so that you understand what I'm trying to talk about. Okay. Same applies to this other one, letter h. Since you have cos y, and you also have, since you have cos y, and you also have x there, meaning you have two functions that are multiplying themselves. So to differentiate that using implicit differentiation, you split them into two and use the product rule. So you can say your x is equal to u, and then your cos y is equal to v, and then you differentiate that. And after differentiating, you come and replace your expressions in the product rule formula. So let's do this one. Okay, so the question is tan x plus y is equal to x. So this is the question, and to find the derivative of this, we first have to okay, we can use what is called chains rule. So to use chains rule, we're going to equate what is in the brackets there to u. So we're going to say let u be equal to x plus y. So we find du dx. So du dx is going to be equal to, when you differentiate this, you get 1. Differentiate y with respect to x, you're going to get dy dx. And then this is what we have as du dx. And then let's also write this expression. So we're going to have tan in terms of u. So we're going to have tan u, because we said this part is equal to u. We're going to have tan u is equal to x. So now let's differentiate the whole expression, because we know that the chains rule states that dy dx is simply just equal to du dx times dy du. This should be such that if you multiply them, that and that should cancel, so that you just remain with dy dx. Okay, so we know that the derivative of tan u is simply just sec squared u, and then sec squared u, that's the derivative of tan u. So this part alone, we're using the chains rule. So on this part alone, we're using the chains rule. So I'm not going to write the whole expression first. I've just gotten this part alone. So I'm going to say so I'm going to say my dy dx, or not really dy dx. So I'm going to say the derivative of this part is simply first found by getting the u dx. So du dx is what we found here, which is 1 plus dy dx. Then we're multiplying this part with dy du. So in this case I'm not using dy because I just differentiated this function alone. So that function alone, which is here, is the one that we're going to put at this point. But we're going to put the derivative of that function. In short, I was supposed to say let f of x be equal to this expression alone, so that you see the steps clearly. So this other part is going to be replaced by sec squared u. Then after replacing that by sec squared u, we can now say this is equal to the derivative of x is simply just 1. But in this case, the value of u is given by x plus y, so we can replace back that. So we're going to have 1 plus dy dx multiplied by sec squared x plus y. I've just replaced the value of u back into that expression. So here it's just a matter of making dy dx the subject by just you can multiply through by sec so that you remain with so okay, let me just do it quickly, or I'll not follow steps because there's no space here. So I'll just say dy dx sec squared x plus y is equal to 1. When you multiply sec and 1 there, and then you take it to the other side of the equal sign, you're going to get minus. You can follow the steps bit by bit and you see if the solution I'm going to get will be the same as yours. So say minus sec squared x plus y, and then when you differentiate, when you divide everything by sec squared, when you divide everything by sec squared x plus y, you get your dy dx as 1 over sec, and we know to say 1 over sec is simply just the same as cos. So anyway, let me just write it the way it's going to come out. So 1 over sec squared x plus y, then we say minus this over that. The answer is simply just 1. So this part can also be changed to just cos squared x plus y. So this is how you do the differentiation. So this one, like I said, you just have to use product rule. Then you replace the values there. The value of x you put 2, the value of y you put pi over 3. Even on this one, you replace with these values. You put the value of x there, and you also put the value of y there to find the answer. We know that cos 1 is equal to cos 0 rather is equal to 1. So 1 over 1 will give us 1. 1 minus 1, the answer is 0. Okay. Alright, thank you very much for watching today's tutorial. See you in the next tutorial. If you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button. If you have any questions, corrections, in case I made a mistake as I was solving, you can simply just contact me using any of my lines here on the screen. And if you need further help in math, you can contact me using the same lines. They are on WhatsApp. And also don't forget to click the notification button. My name is Harmtedy. Shalom, shalom.